Welcome to Lesson 11 of Module 3, Quadratic Graphs. So we started looking at the graphs of a quadratic in the previous lesson, but we're going to dive a little deeper in this lesson. So here are some characteristics of quadratic graphs. The shape of the graph is called a parabola. It's a U-shaped graph, and it can be concave up or open upwards or concave down. So if your A value in standard form or in any of the forms of a quadratic is greater than 0, that means that the graph is concave up. If the A value is less than 0, then that means that the graph is concave down. The vertex, which we spoke about, is your highest or lowest point. The x-coordinate of the vertex can be found by using the same equation for the axis of symmetry, which is x equals negative b over 2a. Then to find the y-coordinate, you would just substitute the x value into the equation. But I recommend using the graphing calculator and just graphing it to find it. And then your axis of symmetry is the vertical line that goes straight through the vertex. And then, of course, you have your y-intercept and your x-intercepts. Remember, your x-intercepts are your solutions, your roots, your zeros. So let's take a look at this graph here. The equation of this parabola is y equals the sum of x plus 2 squared minus 4. First, let's find the vertex. So the vertex right here is its lowest point, and it's at negative 2, negative 4, right? Here's 0, 0. We go negative 1, negative 2, down negative 1, negative 2, negative 3, negative 4. Does the parabola open upwards or downwards? Well, we can see on the graph that it's concave up, it's open upwards. And if we didn't have the graph, we can just look at the equation, and because this a value is positive 1, right? The a value in this form would be the number outside of the parentheses, the coefficient here. And since there is no number here, we know that it's positive 1. So since a is positive, it's concave up. What is the y-intercept? The y-intercept here is at the origin at 0, 0. And what are the x-intercepts? They're at negative 4 and 0. So your solutions, right? What are your solutions? The solutions are negative 4 and 0. Please pause this video and work on the Lesson 11 Level 1 problems in the workbook. In Level 2, we're going to look at the standard form versus the vertex form. The standard form of a quadratic is y equals ax squared plus bx plus c. Now, we're going to look at the vertex form as well, which is y equals a times the difference of x and h squared plus k. Both of these forms give us different information about the graph. So what does the standard form tell us? Well, the standard form gives us the y-intercept. We can look at the value of c, which is negative 1 here, and that is going to be the y-intercept of the graph. So if you're needing to find the y-intercept or the initial value, being in standard form is helpful. Well, what does the vertex form tell us about the graph? Well, think about the name, vertex form. It tells us the vertex. So when your equation is in this form, the vertex is hk. So notice how our vertex is negative 1, negative 2. Now be careful here. A lot of students tend to make this mistake, and they would look at this equation and say that the vertex is at positive 1, negative 2. But that's not the case, because look at the formula. The formula here is x minus h. This minus h basically means that it's the opposite sign, right? So since we have x plus 1, we have to take the opposite sign of positive 1, which is negative 1. And the y value of the vertex, the sign stays the same. So it's just the x value. You have to remember to switch the sign. Let's take a look at an example. The graph of a quadratic function is given. An equation that represents the function could be, so we're given the graph, and the first thing I notice is that it's concave down. That means that the a value has to be negative. So I'm going to cancel out a and c initially because they both have an a value of positive 1/2. So I know that it has to be either b or d because they have an a value of negative 1/2. So next I'll find the vertex. The vertex is at positive 15, positive 25. So if you just substitute into the vertex form, I know that the equation would have to include x minus 15, remember the opposite sign, and then plus 25. So that would be choice D. Please pause this video and work on the Lesson 11 Level 2 problems in the workbook. In Level 3, we'll talk about the factored form. The factored form of a quadratic is f of x equals a times the difference of x minus p times the difference of x minus q. Right? So it's just your quadratic equation factored. Now, if we look at the graph here, notice how your zeros are at -2 and positive 3. So what would that be in factored form? In factored form, that would be f of x equals x plus 2 times x minus 3. But I thought that the zeros were at -2 and positive 3. Well, remember, when we solved quadratics by factoring, we set the factors equal to 0. So setting each factor equal to 0 and solving for x, you would get x equals -2 and x equals positive 3. Please pause this video and work on the Lesson 11 Level 3 problems in the workbook. Once you're finished with the problems in the workbook, please stop this video and move on to the next one for Lesson 12.